This is section 3.3, part 1 of rates of change and behavior of graphs. Let's begin with talking about the average rate of change of a function. It's very similar to slope. The average rate of change between two input values is the total change of the function values, the output values, divided by the change in the input values. So as you can see here, this is the change in y over the change in x. Remember, f of x equals y. Anytime you see f of x, we want to think about y. So these are y values divided by x values, and of course they're the difference in those. Okay? So here are the steps. If you're given the value of a function at different points, calculate the average rate of change of a function for the interval between two values. You'll be asked to find the average rate of change between two values, let's say x1 and x2. The first thing you'll do is find the difference of the y values at those 2 points, and then you'll find the difference of those two x values and find the ratio. Let's give this a try. Using the data in the table, find the average rate of change between x equal to 2 and x equal to 5. So we're going to start with our second point. Sometimes I like to write average rate of change like that. You may not even write anything. So let's start with the two y values. 1 minus 17. Those are the change in the y values there. And now we'll subtract the x values, 5 minus 2. So we get a negative 16 over 3. Okay, how about between 2 and 4? So what are we going to do this time? We're going to have the average rate of change is, so now let's subtract those y values, 5 minus 17 over 4 minus 2. So remember, we want to get the y values that are associated with those x values. Okay? So those go together, and these go together. And I can do that here as well. This is a coordinate, and that's a coordinate. Okay? So that's where we get 1 minus 17 over 5 minus 2. 5 minus 17 over 4 minus 2. So here we have a negative 12 over 2, and we can simplify that to negative 6. Okay, now let's try graphical. This is the numerical method using a table. Now let's try the graphical method of finding the average rate of change. Now this time they want on the interval from negative 1 to 2. What that says is from x equal to negative 1 to x equal to 2. Okay? What was that average rate of change? You could also use the word between. You could say between those, okay? So let's go ahead and take a look on our graph. X equal to negative 1. We have a y value of 1. X equal to 2, go all the way up here. We have a y value of 4. So if you're really interested, what we're really doing is we're finding the slope. We're finding the slope of the line that connects those 2 points. That's really what we're finding. Okay, the average rate of change is, let's take those y values, 4 minus 1, divided by 2 minus a negative 1. and we end up with 3 over 3, and that's equal to 1. Okay, let's try this next problem. In example 3, after picking up a friend who lives 10 miles away and leaving on a trip, Anna records her distance from home over time. So, at 2 hours, she's 90 miles from home. At 5 hours, she's 240 miles from home. So as you can see, this table gives us the distance she is from her home over time. Find her average speed over the first 3 hours. So, taking a look at this, over the first 3 hours would mean between time 0 and time 3. So, we're going to have x equal to 0, y equal to 10, x equal to 3, y equal to 153. So the average rate of change are those y values subtracted divided by the x values subtracted. So we end up with 143 divided by 3. So we can see if we can simplify that. And we cannot, so we will just leave that as 143 over 3. How about this? You could also give an approximately. I got about 47.67. Let's look at our units. In the numerator, these were miles. In the denominator, these were hours. So we could put miles per hour. Okay, how about over the first 5 hours? That would be from t equal to 0, or between t equal to 0 and t equal to 5. So x equal to 0, x equal to 5. She was 10 miles from home at time 0 and 240 miles from home at the 5th hour. So our average rate of change is 240 minus 10, that's the difference of those y values, divided by 5 minus 0. So we end up with 230 divided by 5, and we end up with 46 miles per hour. And if you're writing MPH, that's okay as well. So that's another example with numerical. Now we're going to try algebraic. This one seems to be the most challenging because we can't just see these y values in a table. We actually have to find those. So let's go ahead and use our average rate of change equation. So if we're on the interval from 3 to 16, we want to know the average rate of change between x equal to 3 and x equal to 16. So we're going to have f of 16 minus f of 3 divided by 16 minus 3. So f of 16, let's go right below f of x and find f of 16. And that is 16 squared minus 2 root 16. So 16 squared is equal to 256 minus 2 times 4. So we're subtracting 8 and we get 248. So we have 248 minus, now let's find f of 3. That's 3 squared minus 2 root 3. Kind of a mess. 9. Oh, why don't we go ahead and find this first? So that's 9 minus 2 root 3. And that's 5.536. Divided by 13. And let's see if we can find that. 248 minus 5.536. We get 242 divided by, 242.464 divided by 13. And we end up with 18.651. And that's our answer. We didn't have any units on that, so we just leave it like that. Okay, and our last problem in this part is the same, except we want to find the average rate of change between x equal to 0 and x equal to a. So we're actually going to have an a in our answer. So let's go ahead and get this set up. The average rate of change is going to be f of a minus f of 0 over a minus 0. So let's go right under here. And actually, instead of me saying f, do you see that our function is called g? So it's probably better to say g of a minus g of 0. Okay? So let's go and find g of a, and we've practiced this. That's a squared plus 5a plus 1. And then let's find g of 0. And g of 0 is 0 squared plus 5 times 0 plus 1. And we just get 1. So we have a squared plus 5a plus 1 minus 1. So this is g of a, and this is g of 0 all over a. And we end up with a squared plus 5a over a. And let's divide each numerator by a. So we have a squared divided by a plus 5a divided by a. And we get a plus 5. And that concludes this first part of section 3.3.